This is review video 46, acids, bases, and K values. We already know that some acids are considered to be strong and some bases are considered to be strong. What that means is that they break up completely when they come into contact with water, but not all of them do that. The weak ones do not break up completely in water. To evaluate whether or not an acid or a base is strong or weak, we could memorize all the strong ones, which is completely achievable. But in terms of deciding, okay, well, is this weak acid stronger than this other weak acid or whatever, we have to start looking at K values, which are just like the K values that we have come into contact with so far, and we evaluate them based on an equilibrium system, products divided by reactants raised to the power of coefficients. Any strong acids or bases are going to have large K values, whereas our weak acids and bases are going to have smaller K values. So keep in mind that this K is not different than any of the ones that we've talked about so far, but you are going to see another different subscript. If you see Ka, it means that it's an acid dissociation constant. And if you see Kb, it's a dissociation constant for a base. Similar to your KSP values, which were a solubility product dissociation situation, it means the same thing. So let's look at a couple of examples for our equilibrium systems, all right? This first equilibrium system represents a generic acid HA coming into contact with liquid water, and then in that association is going to form a hydronium ion and that A-, that leftover ion from the acid. And so if we were to write this expression, we would do products divided by reactants raised to the power of any coefficients, making sure to exclude anything in solid state and anything in liquid state, just like always. So our two products over here, we have our H3O plus and our A-, which is just a generic anion. And on the bottom, we have our reactants here. But notice that water is a reactant, but it's in liquid state. So we are going to exclude that one from this expression. So on the bottom, we would just have our generic acid, and that is our Ka expression. For our base, our generic XOH base, again, that's going to come into contact with liquid water, and it's going to produce a cation and hydroxide. So once again, we're going to do products divided by reactants, and once again, water's in liquid state, so we would leave it out completely. So we're going to have that X plus and our hydroxide ion, and then on the bottom, we would have our generic Arrhenius base. Now, in terms of why these expressions mean, okay, if I'm a strong acid, if I'm a strong base, I have a big one. If I'm a weak acid, a weak base, I have a small one. It's all about dissociation. We know already that to be considered strong, our acids and our bases have to produce a lot of H3O plus or OH minus, right? So it makes sense that if I'm a strong acid or a strong base, I'm going to end up with a lot of product at equilibrium. And if you have a lot of product at equilibrium, you have a large K value. And so again, it's the same exact K that we've been dealing with. We're just specifically talking about acids and bases now. In terms of which compounds are strong acids, which compounds are strong bases, there's these tables that you have seen before. So we have hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, chloric acid, and perchloric acid on our list of strong acids. Over on the right, we have our list of strong bases: lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium, cesium, calcium, strontium, and barium hydroxide. On the bottom are a couple of commonly known weak acids and weak bases as well. And I told you back then, you could memorize these tables, absolutely, because you are responsible for knowing which acids and bases are considered strong on the AP test. They will not always tell you directly. But memorizing a table like this always comes with the risk of forgetting something. So there are a couple of shortcuts that I want to let you know about. The first is halogens, except for fluorine, are going to produce strong acids. Because look at the top three: Chlorine's a halogen, bromine's a halogen, iodine is a halogen. So if we look on the periodic table, these three halogens produce strong acids. Down here, these bottom two, we won't ever deal with those, so you don't have to worry about that. The only halogen that does not produce a strong acid is fluorine. The reasoning I will tell you about later. The second shortcut is our 8 polyatomic ions will produce strong acids except for carbonate. So we look back at our list. This is nitrate, that's sulfate, that's chlorate, and that's perchlorate. So any of our 8s except for carbonate are going to produce strong acids. Again, the reasoning for that I will give you later. But if you have an acid that's with an 8 polyatomic, it's very likely to be strong. All right? The next one is group 1 and group 2, except for magnesium and beryllium, are likely to produce strong bases. So if we look at our list of strong bases over here, lithium's in group 1, sodium's in group 1, potassium's in group 1, rubidium's in group 1, cesium's in group 1. Calcium's in group 2, strontium's in group 2, barium's in group 2. All of those from group 1 and group 2 of the periodic table, all of these produce strong bases. These produced strong bases. Technically, francium would produce a strong base as well, but again, we don't need to usually deal with it. Same with this one down here, radium. But our exceptions to that rule are beryllium and magnesium. So again, if you have a base made up of hydroxide and something in group 1 or group 2, it's very likely to be strong. Again, there's always going to be exceptions. The ones I crossed out are going to be your exceptions. And then one weak acid that is an 8 that you do absolutely need to know about is acetic acid made up of hydrogen and acetate. That's just a common example. All right, so that for me is easier to remember than trying to memorize the entire table, so I hope that that helps you. If you have any questions about any of this, please let me know.